Hey guys, is this recording? Yes. Hey guys, so today for Lab 8, we're going to go over correlation. And on the lab sheet, the first question is going to show you a set of scatter plots, and your job is to interpret these scatter plots. I'm sure you'll do something in class with this, so it should be pretty intuitive. But just a brief review, since some of you might be learning this for the first time. When you look at these scatter plots, you should consider three things. Consider the form of the scatter plot. So think about like how linear or non-linear the data is. Like you can see we have some data that's just like random. It doesn't really look very linear at all when you compare it to something like C, for example. So this is linear data right here. This would be non-linear. Uh, Also consider the strength. So the strength of association you can tell by looking at how the data points or the subject are clustered around like a line, like a best fit line. So if you're comparing B and C, C has a stronger association than B does because you can see how close these data points are to the mean as opposed to B. Uh, Another thing you should consider is the direction. So basically, which way, like, are you seeing a positive association or a negative association? A positive association is when two variables increase. So like, as a person gets older, they become more intelligent. So you can see, if a x-axis was intelligence or age maybe, and then the y-axis here was intelligence, you could see that they both increase together, and that's where you get this line. Conversely, you can have a negative association, so that's when one variable is increasing while the other is decreasing. So trying to think of an example on the fly here. Uh, Number of friends equals less time alone. So less time alone would be the y-axis, and then more friends equals the x-axis. So as someone has more friends, they have less time alone. And it's probably not true, but um, yeah, just to illustrate this relationship. So essentially, going back to it, a positive association is two variables increasing simultaneously, and a negative association is when one variable increases while the other decreases. Uh, there's also no association, which you can see right here on the bottom. So um, when you look at these graphs, and I know I gave you the answers here, but try and consider why these are like YE is considered a perfect negative association. Well, it's considered a perfect negative association because of the form of the data. So it's linear. The strength, it's a perfect negative association because look at how these data points kind of like line up together around the mean, as opposed to A, for example, which has a strong negative association. And then the direction as well. So it's negative because one variable is increasing while the other is decreasing. So again, look at um, the direction of E compared to A. They're both still negative. It's just that one is stronger. One is more perfect than the other, or stronger, I guess you should say. Um, D has no association because it's not linear. So we have it's scattered out. The strength, there is no strength because like one variable is increasing, or I'm sorry, that's the direction. The strength, they're not clustered around some sort of like line or average. They're just kind of like spread out everywhere. And then the direction as well. It's not really like, it's not positive, it's not negative, it's just kind of randomly scattered about, not randomly scattered about, but it's kind of scattered about. So we would say no association. Okay, let's get to the good stuff. Hey, hey guys, you might be wondering what is going on in this video right now. We were going over a presentation and then you just cut out, well, last year we were using R and this year we're using Jamovi. In order to find these scatter plots and correlations, it's going to be a little bit different. So very quickly, we are going to make a scatter plot, which is super easy. I actually don't need this at all. So we have our data set imported here. Going to go to exploration. We're going to go to scatter plot. And then we're going to make our scatter plot. Super simple, very straightforward. So an example would be, don't quote me on this, but I believe height was at the y-axis for one of them. And then let's just double check. So average parent height is going to be on the axis. And then we get this lovely little scatter plot here. All we need to do is throw in that best fit line. The problem here is we don't have the correlation. So after you've copy and pasted this onto your lab worksheet, you'll give the form for it. So this is a linear relationship. It's strong to moderate. We can see how everything's clustering over here. And it's a positive relationship, obviously, because as somebody's average parent's height increases, their height also increases as well. So these two variables are increasing or decreasing at the same time, if they're positive. But the issue is we need some sort of like correlation to work with, right? Otherwise, this stuff doesn't, how are you going to tell people about it? So in order to do that, we will go to, once I can find it, I believe it is correlation matrix. And we get this down here. I think it's just easier to throw in all of the variables that you're supposed to be working with. So let's go average parent height, we'll go income, we'll go calcium, and oh look, it's actually right here. So let's just go ahead and throw these in. Average parent height, income, and calcium. All right, bada bing. We got Pearson checked off. We're going to flag these significant correlations. We need the N so that we know how to say our APA answer. And look at that. It's that simple. So what I would do for question 3 is make all these scatter plots individually and then go back here and then to Jamovi and then enter everything in as a correlation matrix into the correlation matrix. It's just so much easier that way as opposed to doing one and one, two variables at a time. And once you've done that, you'll be able to give your APA style responses. Here's an example. So, whoops, we'll use a different example. So average height or height and average height of parents, in keeping with this example, were strongly positively correlated, as we said before. And then R is the symbol for correlation. Your degrees of freedom here, I believe it's n minus 2. We have the actual correlation, which is evident by this average height, correlation, and then this is the p-value, which we've included here. And that's it. You guys are going to do great. Let me know if you have any questions.